This is Module 2, Lesson 4, What are reflections and their properties? Please go to the website listed right here and observe what happens when you slide the button. Observe what happens in the picture. There are 2 points on either side of the line, and you want to observe what's happening in the picture. Please pause the video while you do this. Let's review what happened in the video. When the paper is reflected over the line, the point on the left flipped to the right, and the point on the right flips to the left. But the point on the line stays on the line. You were doing a reflection. The dotted line did not move or change. It acts like a mirror. This line is called the line of reflection. The reflected figure, which is the image, is labeled the same way we labeled figures for translation. So point A would map to A prime, point X would map to X prime. Same labeling as we did in translations. Now do exercises 1 and 2 on page S12. Okay, number 1 said to reflect triangle ABC and figure G across the line and label the reflected images. So here we have triangle ABC, and when you reflect it over the line, it's the same triangle, but notice if you folded the paper along this line of reflection, since B is on the line, it stays the same. A flips over to A prime. C flips over the line of reflection to C prime. So they are now mirror images of each other, the same thing that would happen if you looked into the mirror. The next figure that you had to reflect was figure D, and figure D was flipped over, and now we have the image of figure D. And that looks exactly the same, but it is a mirror image. So let's look and see why these mirror images look the way they do. First, let's answer question number 2, which said, which figures were not moved to a new location on the plane under this transformation? So what things in this diagram did not change? Well, the line of reflection didn't move, and point B didn't move. It still is in the same spot, but on the new image, we're calling it B prime. So those 2 were not moved to a new location. Let's observe something else. If we have other images, such as A over here, A, which is a slanted T, and then if we reflected it over the line of reflection here, we get A prime. And here we have B is a line, an arrow here, and if we reflect it over this line of reflection, we get B prime. Let's notice what happens when we reflect those. And you should be doing this with your transparencies so that you can see for yourself how these reflections work. It's better if you're actually doing this with transparency paper. So L is the line of reflection. The figures in red are the reflected images. T was left-leaning. T was right-leaning. But after the reflection, its image is left-leaning. So if you look up here, T is right-leaning, it's leaning to the right, but after you reflect it, it's leaning left. Image B was pointing to the right, now it's pointing to the left. That's the other change. The up and downness did not change. Right? The cross in T on the top, and the cross in T in the pre-image is still on the top. So they're still on the top, so that didn't change. The up and downness didn't change, just what changed was left to right. Now let's observe what happens when we reflect over our horizontal line. Here we have a horizontal line, and there's an image T, a pre-image T, and its image T prime over a horizontal line. So the up and downness did change. It flipped over the horizontal line. But notice the tail of the object is still on the right. The tail of the object is still on the right. And for both the pre-image and the image. So that didn't change at all. So just as before, the image is reflected. Now the left and right of the figures are the same, but the up and down have changed. They're mirror images of each other. So now please stop the video and watch and do exercises 3 to 5 on page S13 and S14. Number 3 says, reflect the images across line L. Label the reflected images. So let's do that now. Now let's look at the reflected images across line L, problem number 3. When we reflect the circle across the line, the circle right here, we get the circle, the image in red. Notice the position of J and I. J is the same distance as J prime from the line of reflection, and I is the same distance as I prime is from the line of reflection. The two angles are also reflected. B is the same distance as B prime, C is the same distance as C prime, and A is the same distance as A prime. So let's answer these questions. Use a protractor to measure the reflected angles. So if you weren't that accurate, it's okay. What you wanted to notice is that the angle and its image are the same, about 66 degrees. Use a ruler to measure the length of the image IJ after the reflection. Well, you should have noticed that the line segment and its image are the same, about 5 units. Reflect figure R and triangle EFG across line L. Label the reflected images. So here, figure R is here, and when you reflect it over line L, you get this figure here. They're the same distance from the line of reflection. It's just like looking in a mirror. The same thing with the triangle. Point E and E prime are about the same distance apart. F and F prime are the same distance, and G and G prime are the same distance from the line of reflection. A way to reflect this nicely would be to, if you took a piece of paper, drew a straight line, and darkened it in, drew a triangle on the line the way this triangle EFG is, and darken it in, darken in the edges, really darken it in with a pencil. Then fold the paper along this line of reflection and rub with like a pencil so that the markings on the triangle rub off onto the other side of the paper. When you open it up, you will see the image. You'll see the after effects of this triangle you had darkened in with pencil. We can try to practice that more in class. So what we should notice is that the properties of reflections are so far about the same as they were for translation. A reflection maps a line to a line, a ray to a ray, a segment to a segment, and an angle to an angle. A reflection preserves lengths of segments, and a reflection preserves degrees of angles. What is new, though, is something I want to explain now. If we draw a straight line down, call it line L, and we have point P on one side of the line, and we want to reflect it over the line. So here we have point P, and we're reflecting it over the line, and we're getting P prime. And I put in O on the line, just so we have a marking on the line. And what you may notice already, or just assume and not even realize, is that the distance between P and O is the same as the distance from P prime and O prime. It makes sense because they're the same distance from that line, because that line is like a mirror. So because of that, we can make another rule or another property. That the line bisects or cuts in half the segment here. If we connected these two, like I did kind of here, if we connect them, that means this line right in the middle is bisecting or cutting in half the segment we just created. This is because each point is the same distance from L. So O on the line is the midpoint, and OP, line segment OP, is equal to line segment O prime P prime. Sorry, OP. Just OP prime. So then another property that we have with translations is that if you have two parallel lines, when you reflect them, their reflections will also be parallel. And we discovered that in lesson 3 that was the case. Now complete exercise 6 to 9 on page S15. For this one, question 6 said use the picture to label the unnamed points. So for angle ABC, over here, angle ABC, if we reflected it across this line L, the unnamed points would be A on the top, B in the middle, and C on the bottom. That would be A prime, B prime, and C prime. For this triangle down here, I, J, and K, some of the notation was missing. So the top triangle was the pre-image, I, J, K. J was missing, but J was down here as prime. This would be I prime, this would be K prime. Okay, make sure you're seeing that this point here is I prime, just like this is I. It's not K. We're not sliding this triangle. This triangle is not sliding. It's being reflected. It's flipping over this line. Okay? Now the last two figures, this was H and F down here on the bottom. When you fold it over or flip it over the line of reflection, this point here becomes H prime and this becomes F prime. Question 6 says, we label the points. What is the measure of angle JKI? Well, that should be 28 degrees. What is the measure of angle KIJ? That should be 31 degrees. And angle ABC is 150 degrees. Because reflections preserve angle measure. What's the length of segment? The reflection, this terminology here, notation, means the length of the segment that was formed when you reflected FH. And they also want to know the length of the segment when you reflected IJ. So FH is 4 units and IJ is 7 units, because reflections preserve lengths of segments. Question 9, what is the location of the reflection of D? Point D and its image are in the same location. Point D was not moved because it is on the line of reflection. So just to summarize, we know that a reflection across a line is a basic rigid motion, just like a translation was. They have the same properties as translations. Reflections map line to lines, rays to rays, segments to segments, and angles to angles. Reflections have the same basic properties as translations because they too are distance and degree preserving. This new property, the line of reflection L, is the bisector of the segment that joins a point not on L to its image, which we observed in this example here. This concludes the lesson for lesson 4, and now you can review it if you'd like, but we'll be discussing it the next time we meet.